Welcome, everybody. Mitakuye Ayasin. My name is Annette Lee. I am mixed race Lakota, and my communities are Ojibwe and Dakota Lakota. I'm here at Minnesota Makoche, Minnesota. I greet you with a good heart and welcome you to our gathering. This is Native Skywatchers. This is our NASA-funded project, Two-Eyed Seeing, a special bonus event, Arabian Indigenous Astronomy and the Stardust Project. So with a good heart, I welcome you, and I'm so glad that you made it. So this is all about Etowaptamunk, which was given to me by my Mi'kmaq colleague Carola Knockwood from Nova Scotia, and this means two-eyed seeing, and it means, well, just that, to see with one eye, Indigenous knowledge, to see with the best in the other eye, with the Western science or Western knowledge system, but to see with both eyes for the benefit of all. And that's the key part, to see with both eyes for the benefit of all. And so maybe you've been to some of our other events. We're worked really, really hard these last 8 months. And there's these recordings are all posted on the website, so you can watch them. I want to acknowledge that this did start off as a NASA-funded project, but this is a bonus event. So we do have Lowell Observatory supporting this, and UC Santa Cruz. So along with Native Skywatchers. So we thank everyone. With that, we're going to go to the land acknowledgements. So Kate, I would love for you to take it away.
Thank you, Annette. So good to be here. Hey, hello, everyone. My name is Kate Coulter-Rosak. I'm European American of Scandinavian, German, and British Isles heritage. I'm speaking to you today from South High in Minneapolis, Minnesota. These are the ancestral lands of Dakota, the Oshete-Sequin, and later the Ojibwe people. We are here in Minnesota Makoche near Badote, where what are called the Minnesota and Mississippi rivers come together. So we call this land Minnesota Makoche, the precious land where the water reflects the sky. It is so good to be here with you all. Tavia, would you like to go next?
Sure, I would love to go next. Thanks. My name is Tavia, and I'm coming from Baltimore City, Maryland. Every community owes its existence and strength to the generations before them around the world, who contributed their hopes, dreams, and energy into making the history that led to this moment. Some were brought here against their will. Some were drawn to migrate from their homes in hope of a better life. And some have lived on this land for more generations than can be counted. Truth and acknowledgement are critical in building mutual respect and connections across all barriers of heritage and difference. Coming from Baltimore City, we believe it is important to create dialogue to honor those who have been historically and systematically disenfranchised. So we acknowledge the truth that is often buried. We are on the ancestral lands of the Piscataway people, who were among the first in the Western Hemisphere. We are on indigenous land that was stolen from the Piscataway people by European colonists. We pay respects to Piscataway elders and ancestors. Please take a moment to consider the many legacies of violence, displacement, migration, and settlement that bring us together here today.
Okay, Palamia, Danielle, would you go next?
Hi, good morning. I'm Danielle Adams, and I work at Lowell Observatory. Located in Flagstaff, Arizona, Lowell Observatory sits at the base of mountains sacred to many tribes throughout this region, including the Acoma, San Carlos Apache, Tonto Apache, White Mountain Apache, Havasupai, Hopi, Hualapai, Navajo, San Juan Southern Paiute, Tewa, Fort McDowell Yavapai, Yavapai Apache, Yavapai Prescott, and Zuni, as well as the ancient peoples of the Anasazi, Hohokam, Mogollon, and Sinawa. We honor their past, present, and future generations who have lived here for millennia and will forever call this place home. Thank you.
Thanks, Danielle. And Raja, welcome. And do you have a word or two?
Of course. Thank you. Thank you, Annette. Thank you, Kate. Thank you, Tavia. Thank you, Danielle. My name is Raja Guhataputta. I'm a professor of astronomy and astrophysics at the University of California, Santa Cruz. Because of the pandemic, I'm not in Santa Cruz, but I'm going to read our university's land acknowledgement statement next. So the land on which we gather, virtually in this case, is the unceded territory of the Awaswa-speaking UP tribe, the Ama Mutsun tribal band, comprised of the descendants of indigenous people taken to Mission Santa Cruz and San Juan Bautista during Spanish colonization of the Central Coast, is today working hard to restore traditional stewardship practices on these lands and heal from historical trauma. Thank you.
Oh, thank you, Miigwech, Raja. So with that, the other acknowledgement I always feel it's important to make is that we're going through COVID time. So hopefully we're, we see the light, like the vaccines are around, but not everywhere in the world. So I just want to acknowledge that as human beings, we're going through a really difficult time now. Acknowledge all those that have passed away in this terrible COVID time. And also just want to acknowledge our dear friend and colleague, Kalepa Bayan, who had passed away suddenly about a month ago. He was part of our leadership team here as well. So with that, I want to pass the mic over to Danielle. And if you could share your Arabian Indigenous Astronomy, we will be so excited to hear.
There we go. Okay. Well, first I want to thank Annette and Native Skywatchers and by extension NASA as well for really this whole wonderful series that we've been having for much of the past year on Indigenous astronomy. And today I will be talking about Indigenous Arabian astronomy. And I'll be talking about the astronomy that existed prior to the arrival of Greek astronomy in Arabia. And so this is not your typical story of the development of science in Arabia borrowed from the Greeks and passed on to the Europeans afterwards. This is a very different story of indigenous Arabian astronomy. Before I get to that, I want to give you a quick intro to Lowell Observatory. And I am the Deputy Director for Marketing and Communications here at Lowell. And thought I'd give you a quick virtual tour for those of you who may not be familiar with the observatory. This here is our 24-inch Clark refractor, which is celebrating its 125th anniversary this year. This telescope was used to find the first evidence that the universe is expanding ahead of Edwin Hubble's theory. It was used to map the moon for the Apollo moon landings. And today it's used solely for public programming and showing the universe to all kinds of people who come. Lowell is perhaps most famous for having discovered Pluto, which I personally consider still our 9th planet. So here is the Pluto Discovery Telescope on the right and the dome on the left. And we do quite a lot of public outreach. This here is our brand new Giovanni Open Deck Observatory, which opened in October, just a few months before the pandemic closed us down. So there's 6 different telescopes here. This building you see slides on rails to cover all of them when the facility is not in use. But there's also a really fun part This plaza is circular, and there are 6 plinths located around the edges of the plaza. And those are oriented towards the sunrise and sunset locations during the equinoxes and the solstices. So we have our own little Lowell henge built right into this modern observing plaza. And this is how that looks at night. And then, of course, our research isn't just historical. We have 14 tenured astronomers that use all kinds of different instruments. This here is our 4.3 meter Lowell Discovery Telescope, the 5th largest in the continental United States, not including Hawaii, of course. And so, yeah, there's quite a variety here at the observatory. So we've been doing a lot of virtual programming over the past little bit more than a year since we closed our public programming in March last year. And so just wanted to alert you to some events coming up. And all of these are available through our YouTube channel, free of charge for the public, of course. So tomorrow is National Astronomy Day. And there are 2 of these each year. So we'll be doing a special live stream for that. Every Tuesday night, we do interactive stargazing. And that's really unique. We don't just go through a list of objects in the sky and show you them live. If you're on YouTube chat, you can request objects to see, and we'll point the telescope to them and talk about those objects. So it's really fun and interactive from the viewers. And then in less than 2 weeks, we have our first total lunar eclipse in a long time, 2 or 3 years, I believe. It's at an inconvenient time of the night, 2:30 in the morning on May 26th. So that's the morning of Wednesday that week, evening of Tuesday going into that. So we'll be doing a live stream for that as well. So just some things coming up. So let's get to cultural astronomy. There's a question that came in. What are some ways Lowell is accessible? That's an awesome question. Actually, this new observing plaza here is fantastic. 2 of the 4 telescopes are instrumented. We have TVs that you can see. So anyone there can see what's being imaged from the cameras. But then 3 of these 4 telescopes are on these piers, and they actually go up and down. So it makes them accessible for children, anyone in a wheelchair. We're really striving for ADA plus accessibility as much as possible. So great question there. All right, well, let's get into some cultural astronomy. And just a bit on my background, I got my PhD from the University of Arizona, and I was one of those weird people. Either I was the weird anthropologist who also studied astronomy, or I was the weird astronomer who studied culture. But either way, I smash astronomy and culture together and get to cultural astronomy. So it's essentially, instead of looking at the objects in the sky themselves and figuring out, stellar evolution and, planetary orbits, things like that, I look at how people connect to the night sky. And one of the things I really love about cultural astronomy is that when you look at the world, really at the same latitude, we see the same sky. And we're actually going to talk about this a little bit later here. But for example, Lowell Observatory in Flagstaff is at 35 degrees north latitude. So if you trace that line around the world, and I've got not all of it here, but much of it. So if you trace that line going across, you can see we're hitting northern Morocco, Algeria, Tunisia, the Mediterranean there, the Levant with Lebanon, Syria, northern Iraq, northern Iran, Afghanistan, going on. So all of these locations see exactly the same sky, albeit at different times, right? Right now, I'm in a beautiful sunny morning here in Flagstaff, and in the Middle East, it's nighttime. So, but once we get to that point of seeing the night sky and the stars come out, it's exactly the same sky at the same latitude. And so cultural astronomy is unique in that we have the same data points, literally points of light in the night sky. But there's such varied ways that different peoples around the world connect those dots or ascribe significance to those dots. And so that's what we're going to be talking about here this morning. In particular, we're going to look at this region of our map here, Arabia. And there's a number of modern countries that are present here, but my research goes back to starting around 500 CE with Arabic poetry. This is before the development of Islam in the Arabian Peninsula, and my research progresses into the Islamic period, and it examines how indigenous Arabian astronomy developed and was altered and transformed as a result of interactions with different cultures. So that's quite a deep talk. I'm not going to go that deep this morning, but this is the region that we're going to be getting into here this morning. So here we have a beautiful star field. You can see this region of sky very late tonight. We see Scorpius up nice and high in the south. So these are dots, these are data points, right? Now what we do is we, over hundreds of years, stories told around the campfire, we start giving those dots names. And here are just a few of the modern star names given to some of these dots. I've circled some of the more prominent ones that you may know, like Vega, Arcturus, Spica, Regulus, Antares. And so we give these dots names and we tell stories and we connect them to each other. And so then we develop constellations. This is the modern view of constellations, which come to us from the Greeks. And then in modern astronomy, we add boundaries. In modern astronomy, a constellation is not actually the figure that's drawn by the dots in the sky. It's the area of sky that those stars or dots take up. And so you see some very rectangular lines, a bit, you know, there's some weird lines here. And so it's a little bit arbitrary where these lines are drawn. But this is the modern night sky. Everything's flat. Every star has one and only one name. It's in one and only one constellation that's bounded, as you see here. However, the traditional views of the night sky is not this. Constellations and star groupings are not defined by areas of sky. It's defined by the stars and how you connect them and how you draw them. And the Greek way of drawing the stars is not by any means the only way, and it is not or should not be viewed as the one authoritative way of viewing the night sky. There are many other traditions around the world. So what we're going to do today is we're going to break apart this flat view of the night sky and see all of the rich textures, in this case, the textures of Arabia in the night sky. So as we get into the topic of seasonal forecasting, I want to give you a personal story that illustrates what happens in the amazing power that's in the night sky to forecast seasonal change. So this is a view of the night sky from northern New Jersey, where I spent most of my time growing up, not all of it, but much of it. And this view of the night sky triggers memory for me in an instant. What you can see here is the Big Dipper is right there on the horizon, like someone had just placed it whoop, on the horizon. This is a really flat horizon. You know, in my part of northwestern New Jersey, there were lots of trees. And so you've got the Big Dipper just boom, right over the tree line. Now, this conjures feelings of fall, Halloween, and there's a reason for that. So this view is what I would get in northern New Jersey under these conditions. So my location, 41 degrees north latitude, time, 8 o'clock or so, plus or minus an hour, and end of October, Halloween, plus or minus a week or so. So there's something special here. Your view of the night sky is determined by these three things. Your location on Earth, which determines the arcs, the paths that the stars take through the sky, the time of night, and the season of the year. If you know any two of these, you can figure out the third. And so this view is special. I don't see this here in Flagstaff, Arizona. I'm 6 degrees further south, and the Big Dipper dips a little bit below the horizon. It's not completely circumpolar. And so we're going to be looking at how these three factors play into seasonal forecasting. All right. So let's take a look at how the sky moves. And the first element is the Earth's rotation on its axis makes the stars appear to move through the night. And so let's take a look at that. I'm going to go to my planetarium software now. I am using Stellarium, which is a free download. You can just search for Stellarium on the internet and get to it pretty quickly. So this shows how I see the sky right now here in Flagstaff, Arizona. So bottom left, this is Flagstaff where we are. Up here, we've got the date and the time, and we're in real time here. So this is exactly what I see. This is our sun. Okay, so let's advance time. And we'll go a little bit more quickly. This blob here is the moon. So we'll see that as we go through the cycles here. Let's get, there we go. All right, we're approaching sunset now. And our view is looking to the south, okay? So as we get to night, we can see the stars are moving. But how are they moving? And of course, this is faster than real time, but you can see that they're making arcs. And what I'm going to do here is I'm going to turn off the Earth's atmosphere so that we don't get back into daylight as this continues to loop. So we see stars rise out of the east, roughly. And they go up, make an arc. The highest point they get to in the sky is in the south. And then they set into the west. Okay, so this is roughly how these stars are moving throughout the sky. Now, if we look to the east, we can see they're coming out of the east and they're arcing up. They're getting higher as they go to the south. We can also take a look at the north. Right? And here is Polaris, our current North Star, and we can see the stars rotating around the north part of the sky. Okay, so this is pretty basic, but there are some interesting things that happen here when you take the time to observe the night sky. So one of the things we're going to look at is aspect. How does the sky change as it progresses through the night? So we see the Milky Way is rising here. So let's take a look here towards the south. And you see this? it's changing. It came out of the horizon. Now it's going up all the way. This green X here is the zenith. So it's going straight up through the middle of the sky and back down behind us to the north. Let's just pause it here. Now there's a wonderful Arabian piece of poetry that talks about just this thing. The Uruma says, the men with matted hair were cleaving the desert in its middle when the mother of the entangled stars turned. Okay, so the mother of the entangled stars is the Milky Way galaxy. And so this poet is talking about the changing aspects of the Milky Way as it progresses through the night. So as the mother of the entangled stars turned, right? Let's take a look at another piece of poetry. This is even earlier, from 544 or earlier, from Imru al-Qais. And he says, when a thuraya inclined obliquely in the sky, like the variegated gems of a beaded sash, whose folds drape from shoulder to opposing waist. Now this is fun. So let's take a look at this. First, let's find thuraya. And a thuraya is the Arabic term for the Pleiades star cluster. So let's take a look here. There we go. This is a thuraya. And so what I'm going to do, I'm actually going to center on the sun here so we can see a thuraya. And I'll go back, whoops, a little bit. And we'll zoom in. Okay. Whoops, that is a bit too much there. All right. So now we're going to focus on a thuraya. And I want you to notice the aspect of a thuraya. Kind of looks like a flag right now. There's these four stars here, kind of almost in a box shape with a little bit down below. So a bit like a flag. Now, as we start time moving again, all right, we're going to be going up in the sky. Let's get a little bit more. Whoops. There we go. And you can see the aspect of thuraya changing as it goes through the middle of the sky and then comes back down towards the horizon. And we'll stop it as we get close to the horizon. Yep, there's some trees coming into view there. Okay, so now the aspect of a thuraya is very different. It doesn't look like a flag anymore. It's the same shape, it's the same stars, but its aspect, its appearance from us here on Earth is now very different. This, in fact, is what the Imru al-Qais was describing when he said, it looked like the variegated gems of a beaded sash whose folds drape from shoulder to opposing waist. And so we see here, this, it's oblique, it's on a diagonal. This is the shoulder and the sash gets wider as it comes down to the opposing waist. And so this here then is, by poetry, we know that Imru al-Qais is describing this star grouping, a thuraya, as it is getting ready to set in the west. If we zoom out a bit, we can see that we're here in the west. It cannot be in any other location in the sky. So just looking at the aspect, the appearance of stars as they change really makes a difference. And from that one piece of information, we've got a lot of information coming through the poetry. Now, let's take a look at one more piece of poetry here as an example of watching how the stars move through the night. And this is from El-Farazdak, who says, I found no sleep, so I did not sleep during the long night. I observe, do I still see the two vultures? Okay, so let's take a look at the two vultures. Whoops. All right, so the two vultures we need to move the sky a bit more to get to them here. So let's get the sky in motion. All right, so the two vultures are here, which we know as Vega, and here, which we know today as Altair. These two stars were the two vultures in Arabic. And these two modern star names actually derive directly from indigenous Arabian astronomy, not Greek astronomy. So this star, Altair, comes from the Arabic An-Nasr al-Ta'ir, the flying vulture. And it's called that because these two stars next to it have their wings spread out wide like it's flying. This one, Vega, comes from the Arabic An-Nasr al-Waqia. That Waqia became Vega when it was Latinized. And it was called that, it means the alighting vulture, or the vulture that's getting ready to land on something. And it was called that because these two stars next to it, when it gets over to the west, are above it, like the wings that are folded up, getting ready to land. So let's watch these two vultures. So we'll get south centered here once again. So we see that the alighting vulture is way up high. The flying vulture is further down here. And let's progress time. And so in the poetry, the poet has a really long night and he can't sleep. And he asks himself, do I still see the two vultures, or have they set yet? He's describing the progress through the night as he's waiting for the vultures to set. So these are some elements of poetry used to talk about the motion of the stars through the night. Now, let's talk about location. And to do
Hey,
that—
Danielle.
Yeah.
Hey, Danielle, this is Annette. You got a couple of quick questions. Would you be able to answer?
Yep.
Do we know anything about the poets, male or female?
Oh, yes. Most of the poets whose poems have survived are male, which is likely a reflection of later Islamic society. Some are female. The ones I've mentioned so far are male. Yes, I will get to some line drawings a little bit later on. Yep.
Super. Thanks.
Absolutely.
Onward.
Okay.
Thanks for the questions too, everyone.
Yes, keep those coming. Okay, so let's take a look then at the north. And I want to turn on our modern grid system. This is our equatorial grid. Basically, these lines that you see projected into the sky are our latitude and longitude lines on Earth projected into space. So this here is the North Pole, the axis of the Earth projected into space, which becomes the North Celestial Pole. The star right here in the middle is Polaris, our current North Star. Now, in the time period that I'm looking at, we go back into starting around 500 CE and extending into around 1000 or so is kind of where my focus is today. So let's take a step back in time, and we're going to notice right away something intriguing that happens. So let's go to 500. Okay, what happened to the North Star? It's over here. This Polaris, but it's not the North Star. So this is really important. In Arabian astronomy, there is no North Star. Even at 1000, if we go there, there's still no North Star. 1500, we're getting close to having a North Star. But at 500, no way. And so what happens is this star and these two stars together represent the direction of north. And what we see in the night sky is that a lot of the poetry that talks about the North talks about these stars. So, and what we're going to see, there was a question about line drawings. What we're going to see is that in Arabian astronomy, there are some star groupings that we might call constellations, where you connect the dots to make a figure, like the Greek constellations. But there is a lot in the night sky where each star represents an individual. And so there's no line drawings. A dot, a star, is a whole animal or person. And that's the case that we see here in the north. So this star that we know as Polaris was called the Goat Kid, El-Jadi. And these two stars together were called Al-Farqadan, the two wild cow calves. And so together we have these three animals dancing around the North Celestial Pole. And let's get the sky in motion so you can see what that looks like when what we know of as the North Star is actually moving quite a lot as it rotates around the North Celestial Pole. Now I'm going to keep that going as we take a look at what happens with location. So location makes a huge difference. As we're looking right now, we see some stars that never set below the horizon, right? Right around this line here, they never go below the horizon. And that's depends on your local circumstances. If you have a big mountain here, your horizon is going to be lower. But generally, the Goat Kid and the two wild cow calves don't go below the horizon. And some of these stars in what we know today as the Big Dipper don't go below the horizon, but others do. Now, what we're going to see is that in the poetry, there's some really rich description about these stars moving around the North Celestial Pole. One example is from Al-Kumait. He says, she bent down to him as one desired, and he was encompassed, just as the stars of night circle around the pole. And so we have a vision here of actually he is describing his camel, his she camel, who's bending her neck down around her young one, like the stars bend and rotate around, curl around the North Celestial Pole. Another piece of poetry from El-Asha says, for when she set out at nightfall, she was seeing two watchers, the Goat Kid, which does not set, and the wild cow calf. All right, so here's the Goat Kid, which does not set, and the wild cow calf, which also would not set. So sometimes the wild cow calf was referring to this one star, which is a little bit brighter than the other. Usually we see the two wild cow calves together, these two stars. And so, yeah, these stars are rotating around the pole. Now, what we're going to see is that the arcs that the arcs that the stars take through the sky are completely dependent on your latitude. So we're here actually still in Flagstaff, again, similar to northern Iraq, Syria. Let's see what happens if we go further north. All right, so let's go way, way up here. All right, now we're at our Earth's North Pole. Nothing sets. Okay, so that's the North Celestial Pole. Again, we're still back 500 years. No problem there. Or we're back to 500 CE. But that's the North Celestial Pole. It's straight overhead. Nothing sets. All the stars just move around you. Nothing changes. There are no new stars to see at different seasons. It's all the same, and it all just moves around. Now, if we did something different and went to the region of the equator, now what's going on? Well, look at this. Now we've got the North Celestial Pole right on the horizon. Everything sets. Nothing is circumpolar. And so when we're looking north, things arc up over and set. but it's really interesting when you look east. Things that rise out of the east go straight up the sky. They don't arc over towards the south. They go straight up and go straight down into the west. There's some really interesting things that relate to this coming out of, for example, Polynesian astronomy. But I'm not going to diverge into that today here. So this is how the sky moves. So let's take a look at this. Let's make one more location change. Let's go to, say, Yemen. All right. So now we're in Yemen. We can see that we're about 15 degrees north latitude, we can see here. And the North Celestial Pole is quite low in the sky. Okay, so here, the goat kid and the two wild cow calves are pretty much the only things that do not set. All of what we know as the Big Dipper sets below the horizon. This is really important. These stars were the critical stars that were used for navigation to indicate the direction of north. But then something interesting happens in the south. We often think of the North Star as, you know, that if you can find the North Star, you can find your direction. That's easy. That's north, and now you know what's going on. But let's look at the south. And I'm actually going to pause the motion and rewind it a bit. This star is Canopus. It's the second brightest star in the whole sky. The brightest one here is Sirius. Canopus is the second brightest. We can just barely see it from Flagstaff. But here in Yemen, it rises quite high. But whenever it's up, it's in the south. Even here, it's just recently risen. It's quite close to south. This is southeast over here. And if we put the sky in motion, it stays in the south. It doesn't go to the east or the west. It's there in the south. So this star, Canopus, was used by travelers also as a guide star. But because it wasn't always up, it acquired an interesting cultural characteristic. And again, I'm going to pause the sky, and we're going to do one more location change. Let's go to some place like modern-day Kuwait in the Arabian Peninsula. Okay, now if I, whoops, back time up. There we go. This is Canopus. It's up, it's in the south. It indicates the southerly direction, but it doesn't stay up very long. And so there's a piece of poetry. No, this is not poetry. This is a saying. And this extends even to a modern Bedouin in the Sinai Peninsula. They would say so-and-so is like Canopus, or Suhail in Arabic. He rises and immediately returns on his tail. So Canopus could be used as to find direction, but because it was so fleeting, it wasn't always up in the night sky. It acquired this sense of instability. You couldn't rely on this star. So here we go. Where you are in on the Earth, your latitude really impacts the arcs that the stars take through the night sky. Okay, so now there's one last way that the sky moves that we're going to look at. And then this one is going to provide the foundation for us to dig into a little bit of seasonal forecasting. So the Earth's revolution around the sun makes the stars change position from night to night. Now, let's start out here. Okay, so we've got a star field going here, and we've got the sky stopped. Actually, I'm going to stop it all the way so the seconds are not even passing. Now, as we look at the night sky here, I'm going to use a keyboard shortcut. Oh, and actually, let me turn the atmosphere back on. All right, and let's advance towards We'll turn the grid off and we'll advance towards sunset. Get us centered up here so we can see east and west. Okay, so we're shortly after sunset here. Clock is stopped. Now, I'm going to advance the sky with a shortcut on the keyboard here. Each time I press it, we will advance one sidereal day. So, whoops, of course I hit the wrong button. Here we go. One sidereal day each time I press this. Now the stars are not moving, but the sky's getting brighter. The clock is actually going backwards. If you look up here in the upper left corner, what is going on? Well, a sidereal day means you go forward or backward in the Earth's rotation so that the stars are in the same place. But that's not how the solar day works. So what we need to do to get to the solar day is we need a little bit extra time. And so let me go backwards a little bit here and show you how this works. Okay, let's see here. Great. So we see here in the night sky, we've got Scorpius coming up. Okay, great. Keep that in mind. Now look at the clock at the top here. We're at 7:38. So if we advance one sidereal day, we're now at 7:34 p.m. We lost 4 minutes, and that's because it takes 4 minutes less than 24 hours for the Earth to rotate so that the stars are in the same place. But during that almost 24-hour rotation, the Earth has moved on in its orbit a little bit more around the sun. And so to get back to its same orientation with respect to the sun, we need to go 4 more minutes. And that is critical. Those 4 minutes over the course of 365 days add up to 24 hours. Okay, so every night, if you go out at the same 7:38 p.m. every night, you will not see the same sky. You will see a sky that's shifted 4 minutes more every night. And that slight shifting is what allows us to do seasonal forecasting, because the stars change night by night when you keep the time the same. This really important key unlocks everything from my view of the Big Dipper when I was a kid in northern New Jersey to poetry in the Middle East predicting seasonal change. And so something though that helps this process is to have a particular time of night. So let's take a look at a piece of poetry here. This is from this wonderful desert poet, Ruma. And he says, at the moment when the star, which here is talking about Thuraya, the Pleiades for us, when the star had culminated in the waning darkness, and he uses this term ghalas, when the herbage had ripened for harvest, some bent and some harvested already. I love this verse of poetry because this one verse has all 3 elements that we've been talking about: position of the star in the sky, time of night, and time of year. So let's do a little bit of sleuthing here and see if we can figure out what's going on. First, the star had culminated in the waning darkness. So we need to look at the Pleiades star cluster and find when it is highest in the sky. But the time must be ghalas, the waning darkness. I'll come back to that. And then the herbage had ripened for harvest. Some was bent and some was harvested already. So we're right in the middle of harvest time, and that's going to be an important clue. Okay, so first let's take a look at what ghalas means in Arabic. And this is really critically important. Ghalas, this really nice extended definition comes from Lane's lexicon. The darkness of the last part of the night, when it becomes mixed with the light of the dawn or the beginning of dawn until it spreads in the tracks of the horizon. Both signify blackness, mixed with whiteness and redness. Okay, so that whole definition is in one word. You see this a lot in Arabic. There's a lot of meaning that's packed in. So ghalas is basically this time of night when it's starting to get bright, but it's not all the way bright. You can see stars. The glow is spreading along the horizon, but not so much that you can't see any of the stars. So let's go forward in time and see if we can first find ghalas. All right, so let's advance forward. All right, excellent. And keep your eyes out. Yep, okay, that glow. Something like this. Okay, so we can see there's that glow in the horizon. If we look up overhead, still a lot of stars. So this is a good estimate of ghalas. Now here we're in May. So we're in the morning, this ghalas time. And so now let's see if we can find the Pleiades star cluster known as a Thuraya. Nope, we cannot see it here. Okay, oh, there it is. Okay, so it's rising right now, but according to the verse of poetry, it needs to be high in the south, pretty much as high as it gets. So let's keep an eye on that and let's advance through the days. Okay, here we go. And we're moving through solar days now. Okay, so the time is the same. And we're in June now. Okay, it's getting higher, but we're also losing ghalas, right? So now we need to start advancing the sky some more. Okay, we've got ghalas again. Let's go further. All right. Maybe the sky is a little bit bright here still. Let's go back a little bit. Whoops, too much. Okay, something like that, right? So here we are. Looks like August for us. We've got the star cluster in the right spot. We've got ghalas, maybe a little bit too much of that, but pretty good here. So this is pretty much what the poet is talking about. And I'll read that verse of poetry again. The darkness, oh, go back. The moment when the star had culminated in the waning darkness, when the herbage had ripened for harvest, some bent and some harvested already. Now we would have to do some more sleuthing to figure out what kind of plant he was talking about to figure this out. But this is pretty much the view of the sky at that point. So again, position of the star in the sky based on your latitude, or dependent on your latitude, time of night, and season of the year. If you know any two of those, you can figure out the third. All right, so let me just take a look at any questions that have come in. Okay, we're not going to talk about the role here in the presentation, but maybe we can get that, or the role of the moon in the presentation here, but maybe we can get some of that in the Q&A later on. Okay, so now I want to take a look at some circumstances that happen, and these are really important. So position of a star in the sky, you could see just now, when it's high up, it's a bit hard to figure out. There's no reference point. I mean, it's up there, but there's kind of a wide range where you could see a star to be culminated at the top of the sky. So a really practical way to keep these in mind is, again, the three things are position, time of night, season of the year. So if you can look at a star when it's close to the horizon, that helps lock in the position, right? Because we know where the horizon is. And especially if you do it from the same location, even if you have mountains in the way, you can reference stars to those places in the mountains and the peaks or the valleys in the mountains. So there are four circumstances that people look at, and two of these were used in Arabia. So one circumstance is called Heliacal Rising. So this means the sun is approaching sunrise, so it's getting bright in the east, and the star rises in the east ahead of the sunrise. This is probably the most common ones that we see across different cultures. So this was also used in Arabia, Heliacal Rising. It's a bit difficult because you're looking at the star where the sky is getting the brightest. So it only really works for the very brightest stars. If you use it with a dim star, you have to go back further in the night when the sky isn't quite so bright. Heliacal setting. So heliacal means, near the sun. So in the heliacal setting, again, the star is near the sun. It's pretty much the same thing. The sun is just recently set, and the star soon follows it in its setting. A chronicle rising. Here, the sun is setting, but the star is rising. So it's further away in the sky, and this would work for more fainter stars as well, not just the brightest ones. And then cosmical setting. This is the one that was most significant in Arabia. So here the sun is getting to rise. So we're in that ghalas time, which is only in the morning. And the star is getting ready to set. This is an extremely practical way of timing seasonal change, because in the nights leading up to this star getting ready to set, you can see it approach, right? Every day, it's 4 minutes closer to setting. So every day you can see it move slowly, bit by bit by bit, until it gets ready to set into the horizon. So this was the most used. And in fact, you see references in the Quran to stars that set. This was highly, highly significant in Arabia. And in fact, there were also a few instances of tracking things that happen in the evening after the sun is set. And there's an interesting piece of poetry here, actually rhymed prose, excuse me. This is a little bit like poetry, but it's more focused on kind of a rhyme that isn't so structured as poetry. So the translation says, when a Thuraya, which is the same star cluster, is at the top of the head, so it's at the zenith in the sky, then it is the night of a boy and an adze. And what this means is that the adze was like an axe used to cut firewood. So it's cold, and the boy's going out to collect firewood and cut it and build a fire. Well, this happened when it was mid-January. The second verse says, when a Thuraya rises with the sunset, then it is the night of an offspring and a camel. And so here, now we're looking at late October. So it's rising with the sunset, which means it's the chronicle rising. And so this is October, and this is when we've got offsprings who are now going out with their camels, older camels. Offspring typically for camels would be born in the spring. And so now they're a few, 5-6 months old and able to go off with the other camels. And then the third verse says, when a Thuraya sets with the sunset, then it is the night of wind and rain. And so here, a Thuraya setting with the sunset is going to be the Heliacal setting. This will occur in April. And this is a time where we have wind and rain coming into the seasonal happenings. So here, this is a really easy to memorize rhyming verse that just uses a single star cluster as the basis of a whole very simple 3-point calendar. So of course from here, it does get more complex. And so we'll take a look now at 2 different systems of one of stars that set and one of stars that rise. And then we'll wrap up after that and give you a fun project to do at home where you are. So first, setting rain stars. So again, in the Arabian context, we're talking about stars that set in the west as the sun is rising in that ghalas period of the morning. So our cosmical setting. And so here I'm going to show you, this is a map of the whole sky. We're not looking at horizons or the earth or anything. This is just the sky itself. So it's a little bit distorted, but this is the northern sky. And here we have in the teal color, the star groupings that are circled. These are important star groupings that were used as rain stars. And this is from a particular calendar of rain stars used by the people of Kusher in modern day Saudi Arabia. And there are 6 seasons in this year, not 4. So the year begins with the setting of these 2 stars. They were the second half of what's known as the well bucket in Arabian astronomy. It's a square bucket because when you're out on camel caravan, you don't bring, I mean, they didn't have plastic back then, of course, but you don't bring a sturdy, say, woven basket with rigid sides and whatnot. It takes up space when it's not being used, especially if you're going to use it in a well. What you do is you have a leather pouch. And when you arrive at the well, you take 2 sticks and you cross them in front at the mouth of the pouch and tie them together. So we've got the 2 sticks here crossed at the mouth of the pouch. And then these 2 little stars here were the crossbar rope. And then you tie the well rope to that. And now you've got your bucket. And so when you're done, you just undo the sticks and the rope and it takes up very little space. So we've got the square well bucket. And what's lovely here is that this starts the year. Let's take a look at this. There's some poetry from Bishr ibn Abi Khazim. The well bucket and a shi'ra, which is the brightest star in the sky, and their rain period rained abundantly upon him as one agitated by all the black clouds drawing near with violent rain. So we've got this beautiful image of the well bucket. And then the 4 stars were called the crossbars as well. And so we've got the front 2 crossbars going to the middle rope where it's tied off, and the rear 2 crossbars. And so as the front 2 crossbars go down, that ends 1 year. And as the next 2 crossbars go down, that starts the new year. So this time of new year in Arabia was a time where the well bucket was seen over the horizon, metaphorically dumping out water onto the ground at a time when the fall rains were just kicking up and getting strong. Beautiful imagery. Okay, now let's go a little bit further. So we've got a Thuraya, which we've seen before. She has a follower. Now this star is also factors in not just when it's setting here, but also when it's rising later in the calendar. It indicates a time of drought when there is no rain. And what's interesting in this calendar is that it's not evenly spaced. When there are stars that set and there's rain when they set, they can be called rain stars. If there's the brightest star in the world, but when it sets, there's no rain, it's not a rain star. So it's very specific here. But this was the follower of Thuraya. And this one appears in some Islamic traditions as well. It was often called al-Mijdah, which means the stirrer up of rain. And then let's look at a couple others. This is El-Jawzat, the 3 stars here in the belt of Orion. This poetry says, there came to him by night a pillar of cloud from El-Jawzat. The north wind drove frozen hail gently upon him. So we know that this is the setting of El-Jawzat. There's hail coming. The time of year here is going to be roughly for El-Jawzat about December maybe late November. Here, I'm going to show you this first and then show it to you in context. This is the Lion. This is the largest constellation I've ever seen. For those who are familiar with degrees in the sky, it takes up 135 angular degrees from the arms and claws here all the way back to the legs. So it was so big in the night sky that in poetry, it was sometimes referred to in the plural. So if we look at this next piece of poetry, it says, he had grazed in the places of the pouring out of the laden clouds, from where the gloomy spring clouds release their sprinkling buckets, a widespread rain at the dawn setting of the lions. So here we're talking about an extended period of time, not just one star grouping, but the lions, plural, numerous of those elements that we saw. And so the heavy rains and winds thundered violently by the dawn setting of the two sky raisers. And that would be these two stars here. They were called the two sky raisers because when they were in the middle of the sky, they were close to vertical, and they were imagined to be the end points of a tent post that would hold up the canopy of the sky. In daily life, they would hold up, that tent post would hold up a tent. So the two sky raisers. Now let's take a look at just a couple examples of Heliacal Rising. And again, here we have the rhymed prose coming into effect. And I'm going to read this in Arabic so you can get a sense for the rhyme. So this says, إذا طلع النجم فالسيف في حدم والعشب في حتم. You can hear that M sound at the end. So this says, when the star rises, again meaning a thuraya, the summer is vehement and the herbage is brittle. Okay, so we're in the heat of the summer here. The next one, the follower, which we just got introduced to. Again, in Arabic, إذا طلع الدبران حميت الحزان واستعرت or استعرت الذبان. So they all end with this an sound. When the follower rises, the rugged lands abounding in jagged rocks become vehemently hot, and the flies spread like fire. So there are tens of rhymed prose sayings like this that, again, they rhyme, they're easy to memorize, and they indicate things going on. We see here, flies spread like fire, right? When it gets hot and dry, the flies are everywhere. Some of these pieces of rhyme prose talk about what people do, and the kids flail about because now it's beautiful weather and they're running around. All kinds of interesting insights into Arabian culture that are coming out of what is essentially a celestial calendar. Okay, so homework, take-home project. We've got these 4 ways of identifying a star that is setting or rising at a time when the sun is setting or rising. And knowing that position of the star and that time of night or day allows us to predict seasonal change. So I would like to challenge you to find your own rising or setting stars that are significant. What could this be? Go out on your birthday, 4th of July, any day that's significant to you, and go out either right after sunset when the stars are starting to appear, or before sunrise, and find a star that is setting at that moment or rising at that moment. And that will be the star that marks that special seasonal occasion every single year until the end of time. All right, thank you so much. I'll give this back to you, Annette. Works.
I'd just like to point out this kind of a comment from Tony said, I'm learning that we are very disconnected from the stars compared to the past people of Earth.
Yes, absolutely. And what's interesting, since I've been studying changes in Indigenous Arabian astronomy, that's absolutely true. There's a whole history behind it that I'm not going to go into right now, but most Arabs don't know a lot of their own Indigenous Arabian astronomy from long ago because it's been displaced. We live in cities with bright lights. We don't see the night sky. We're not up before sunrise. There's lots of factors that play into this. So it's really important to remember.
Agreed. So thank you for sharing. And I'm sure it was just the tip of the iceberg. So we'll circle back to hear more from you in just a minute. So we want to just share briefly this amazing new project that has just taken off. And it's really connected to Danielle's work in that it has a large component working collaboratively with an observatory, which Raja will talk more about in a minute. But one thing that's really cool, and like planetariums and observatories, it's a project for everybody because all of us have in some way a connection, curiosity for the night sky. So how can we do more? We seem like we kind of crave more. I was recently informed by my students in introductory astronomy that it's a huge thing on social media, which I did not know that, like the zodiacs, and there's like tons of apps. So anyways, it's like almost this time where people are really craving to know more, to do more with this connection to the sky, me included. So this is a project, We-Are-Stardust, and it's a collaboration between Native Skywatchers, the organization that I started back in 2007, and then Raja, based at UC Santa Cruz. So We-Are-Stardust. So we're going to give you a quick overview and a few incredible highlights. Okay, so I just want to say that I am an astronomer and a professional visual artist. And I have been teaching astronomy at St. Cloud State, introductory astronomy. This is the end of my 12th year. And before that, I taught 4 years solid faculty in studio art. But the whole time, my practice of art has been ongoing and my connection to the sky, the stars. And I've also been involved in education for a good 35 years. So it's just time flies by, right? So I want to say that this project, We-Are-Stardust in particular, it was born out of really a lifetime of work and my own passion as a person who is very interdisciplinary. And so here you can see that through Native Skywatchers, we've been working for maybe about a decade on creating collaborative videos, storytelling videos, spoken word art, where we would have an elder maybe tell a story, and then I would layer in a lot of the visuals, sometimes historical photos from history museums and archives or collections as well, but a lot of artwork. So it really allowed this platform where it could truly be interdisciplinary and at the same time communicate an idea connected to the sky, rooted in our Indigenous astronomy. So this had been going on. And at the same time, my work as faculty teaching introductory astronomy, this was also blended into Astro 101. So I teach culturally responsive way in my intro classes. And so why shouldn't the class be very participatory and interactive? And one of their final projects was to create a video that would tell their story about their connection to the sky, to the stars. So I just like to say that this project involves participants making content to tell their story about their connection to the sky. And it has 3 parts. The first part is the science story, which could be in any order. The science story, with the lens of science, what is that story about our relationship to the stars, especially that phrase, "We are stardust." And then the culture story. So whatever your connection to culture is, maybe it's ethnicity, maybe it's something bigger, a social group. What is the cultural story about connection to the stars? And third, and most importantly, is that connection, my story. What is your personal connection to the stars? And in this project in particular, besides making the digital video production, like a 5-minute video, the participants are also making an art object that tells this story. So more details on that in just a minute, but I'd like to call Raja, if you want to say few words on this science story part, PJ observing, and how this came about, and your part in this amazing collaboration.
Like many things we are faced with today, you can't have a discussion without talking about the pandemic. That's the most significant thing in our lives. Hopefully, it's the most significant thing in our life. I hope there's nothing worse than this in our lifetimes. But because of the pandemic, we are being forced to do everything in ways that are different from before. And when it comes to astronomy research, it means we can't go to the mountaintop. We can't go to the institution that I belong to, UC Santa Cruz, or any campus really, to operate the telescope. So they've started a mode called pajama mode observing, where you don't have to get out of your pajamas, you don't have to get into street clothes to use the telescope. So it's a remarkable, I think, leveraging of technology today, where you can sit at home, and as you can see on this screen, the left half of the left 2/3 of the screen show you the controls of a telescope that's on a mountaintop that, at least from my house, is 50 miles away. Now, so you don't have to travel those 50 miles. You can be on your living room couch and you can control the telescope. Now, while we were doing this, I was sharing my screen with a group, and you can see Annette in the right third of the picture, and you can see fellow astronomers in the you can see fellow astronomer Ellie Eleanor Gates in the sort of second row left picture. You can see Emily Cunningham. You can see it says 3M ROR, means 3-meter telescope remote observing room. So you can see astronomers who are operating the telescope, and you can see others who would not traditionally be on this Zoom call, would not traditionally be using the telescope, no reason to be, who are sitting in on the Zoom call. It's because we are operating the telescope remotely, it gives us this opportunity to share our remote connection with others. It's sharing a Zoom link, it's making the space to answer questions. That's really all it takes. And I'll just make a quick pitch to say that, we're doing this in our research group. We've done this. We did this last fall. We did this in the spring. I encourage other astronomers to do it. And indeed, I encourage other scientists to do it. I encourage anyone who's interested in making their professional work visible to young people in a way that's unfiltered, unrehearsed, unstaged. Reality, the reality of the professional work. I think the more we make that visible to, especially to young people who haven't had access to this traditionally, the more we do that, the better the world will be. So I'm Raja Guhatakutta. I'm a professor at the University of California, Santa Cruz. We are using what's called pajama mode observing.
Okay, so my first question is, what is the purpose of the star?
From now on, think of that being the purpose of a star, is to create new elements.
My dad's painting shows that everyone that is alive has a spirit and is connected. In the painting, it shows beavers, loons, and stars during springtime. It shows how loons have their babies. See how the trees have no leaves. How I know it is spring. You can see through the animals like an X-ray. My dad says this is how spirits see us. Also on the painting is a bird flying, indicating that it's spring. Our oldest living relative. People are forgetting that they have spirit. It is important that I remember that I have a spirit. Wushu Anid, hello, indigenous cause. My name is Sagian Dodam Adik. My clan is Caribou. The title of my presentation is We Are Made of Stardust.
during their lives, some stars go out of control in a way that causes them to bounce up and down. Not bounce in terms of oscillate, but
This is our measurement. He used the river to start, and then he hit it on the side, and it goes and goes to the base. It goes out on the stars, the falling star, and the canoe, birch bark. And that's what he's going because he's going to go check something. Maybe Mars. That's what they were used to sail on Tampa. They went all over there.
Teaching is that all living things like humans, animals, and plants come from the stars. I also have paintings that are about the Penguin Galaxy. You see penguin in my painting, and yes, there is a galaxy that is penguin shape. It is called NGC.
Okay, Tavia, are you there? Can you give us a little context for these other two videos that were produced?
Sure. Thanks, Annette. I am here. These are two other videos that are produced by Max and Calder, who I happen to know because they are my sons. And much like Raja, I'm a theater artist. So the theaters have been shut down during COVID as well. So we've been doing lots of digital types of performances. And this is actually one of them. I would argue that these are performances as well.
So I'm Raja. I'm Raja Guhatakurta. I'm a professor.
Hi, I'm Calder Hug. Can we eventually travel the speed of light or even pass it? So should we start with the question?
There we go, right there. Okay, so now right here, you can, if things are working right, you can see a rocket right here, right?
Yes.
Okay, good.
This is the satellite or probe. It has batteries, some parachutes, which I don't really need, but I'm still gonna have them in case it fails. I have some solar panels and an antenna. Moon Boy by Calder Hawk. I was born on the full moon, and we like to howl at the moon when there's a full moon. Oh. Yeah. Oh!
Hello, I'm Max. I love space. How about you? I adore space because I like how beautiful it is and how it is amazing and endless. Heavy, like the density of a black hole. Could you move like the singularity?
Wow, that is a great question.
That if humans go faster than the speed of light, do they become spirits? You know. I know you use lights in your work. How do you use those? Like, how do those connect?
Well, I'm interested in lights and spirit.
I have two parents who are artists. I also have one brother called Calder. Wee! 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 I also got two flying sisters, Veggie and Bonnie. They would look at the stars with me.
Super, super fun. Awesome. Do you want to say any other comments right now, Tavia? Great work.
Thanks. I mean, I believe so much in this project. I mean, I am a interdisciplinary, multidisciplinary artist, but I also believe in art as a social practice. And even more, what I believe is making the borders between our works much more porous. So it's so exciting for me to work with scientists and astronomers. And when I see astronomy and poetry going together, I'm just like, whoosh, wow. So everyone should come and jump in the water. It's great.
Thanks, Tavia. Tell us about what's going on there.
Yeah, thanks. Yeah, so So good to be here and so much fun to see everything that you all had to say. And I loved hearing about Vega and Altair. That's just fantastic to know where those come from. Yeah, here at South High, we've got about 15 students, about 5 teachers working on this project. So we've got a social studies teacher and some student support people and student teachers, as well as a dance teacher and some visual artists working together on taking the science story and writing some scripts, and then doing some art and finding, making our science, our art story and our cultural story into something tangible. And it's just so great to see the students asking questions, and love the questions they ask in the PJ Observing with Raja, and to see them come through with these questions and these answers. So very excited to be part of it.
Awesome. Yeah, we're looking forward to
Oh, there we are.
premiering your work at our June 14th and 15th Native Skywatchers 2-day workshop. The last slide, I think I wanted Raja for you just to say something about your incredible project, the SIP project, and this is woven into and a part of that amazing project that's been going on for about a decade, right?
It's been going on for, this is its 13th year coming up. I really see all of this as part of a continuum. I'm a professor at a university where my primary function is to train PhD students to do research in astronomy. I work with students who have passed their PhD as well. And of course, work with fellow faculty who have not only finished their PhD, but they've built up a portfolio of research, and they're now training other young people to complete their PhD. It would be short-sighted if I said I'm going to spend my entire career trying to develop the careers of people so that they can become other researchers like me. That would be short-sighted, I feel, because first of all, a PhD can enable all kinds of careers, not just ones in astronomy. You can get a PhD in astronomy, but you can then become a data scientist, or you can, as many of our PhDs do, or you can, work in IT. You can become a teacher. You don't have to become a professor at a university. You can become a teacher in high school. You can become a teacher at community college. You can spend all your time doing research, not teaching at all, or you could apply your skills to something else. But even there, I don't think it stops there. How do we make sure that we are training a really diverse group of students? How do we make sure that our talent pool draws from everywhere in the world, all circumstances, all backgrounds? How do we make opportunities available? So I made a decision many years ago, now 12 years ago, where I said, I want my work to include high school students. So we started with 3 students from one high school who came to work with me the summer of 2009. This summer, we'll have 300 students from well over 100 high schools from many different countries, from many different states within the United States, who will be taking part not just in astronomy projects, but in projects in 19 different subject areas. One of those subject areas is a brand new one for this year that Annette and I came up with a title for it, which is Art, Culture, and STEM. And what you're seeing in front of you is a project that Annette is going to lead. And it'll have 2 cohorts. It'll have a high school cohort, and it'll have a high school educator cohort as well. The 8 students who are taking part in this, one of them is from India. One of them is, 2 of them are from California. One is from Colorado. 2 are from Minnesota. It's, I think what the students will learn from one another will be just as important as what the students learn from Annette and me. I've seen that again and again. We are starting to take young people from all corners of the globe, really, all parts of the globe, and saying that, look, you have kindred spirits in other parts of the world who are interested in the same topics. And I think the essence of SIP is training students to think on the basis of evidence, evidence-based thinking, critical thinking, and really tackling, in this case, projects and problems that don't have a linear path from a question to an answer. It is very different from how science is taught and evaluated in schools. When you're a school student and you're taking a math exam or a physics test or doing a homework, you know that your teacher has set a problem for you. You know that the teacher knows how to solve the problem. Hopefully the teacher knows how to solve the problem when setting it. And most importantly, you know that there's a path. If you're a good student, you've worked out that path before. But that's not how real world problem solving works. If there were a clear path to problem solving in the real world, we wouldn't be having a pandemic today, or we would have gotten past the pandemic. If there were a clear path, we wouldn't have poverty today. We would have open access to STEM today. There are many real world problems in disease, in environment, in economics, in health, that are open-ended. They don't have easy solutions. Even the world's experts don't have easy solutions. And that's what SIP trains students to think about, work on open-ended problems. I think of this as the deep end of the swimming pool. I think of Starry Night and PJ mode observing as dipping your toe in the water. There's a lot in between, right? We first want you to dip your toe in the water and see if the water feels right. If it does, we can teach you how to wade, we can teach you how to swim until you're ready to dive into the deep end of the pool. That's what I have.
Well said, Raja. And then it can follow up with an REU or undergraduate degree or other things like that. I think another really important part of this project, the We-Are-Stardust and working interdisciplinary in our Indigenous Skywatchers and Native Skywatchers work, it's the idea of whose voices are elevated. And as our Indigenous students and Indigenous community starts, we've been working for a decade to revitalize our Ojibwe and Dakota, especially our star knowledge. And we're to the point where we now have some resources, and it's the idea of getting that back into our school systems. And the amazing thing is that the students themselves and their teachers are participating in this content production. So their own voice becomes the leadership voice, the elevated voice. And I'm really excited about that. So I think we better go right to the larger Q&A. Because I see the time is getting later and later. It has been so awesome to talk to everybody. I just want to say before we open up that there is, what's the next thing? And the next thing is we're planning our annual Native Skywatchers Educator and Everybody workshop, which has always been in person since 2012, nearly a decade. But this year it's going to be online and perfectly free. So look for our registration will be set up very soon. Okay, so let's bring everyone on screen and see if we can take any questions before we close up our gathering here. If you have a question, now's the time. If you didn't already put it in the chat, just give us a question. We'll be happy to hear you.
I'll pop in here. There was an earlier question about the planets in Arabian astronomy. And of course, the planets were observed, but they're not super useful for seasonal forecasting because they move around. They're literally the wandering stars, right? So, so they were observed and known, named, but they don't figure into predictions of what's going to happen seasonally.
Awesome. Danielle, there's a couple of questions for you. One is about the moon, the role of the moon. Maybe you could circle back to that. And then I had a question. This is such great work that you've done and research, and I'm with Tavia, like how exciting to relate this to poetry. I was wondering if you have plans, like what's your next thing? And are you in the process of creating more visuals? Like, so that would this possibly be on Stellarium so we could have greater access to this incredible work that you're doing? So role of the moon and future steps.
Sure. Yeah, so for the moon, later on, well, okay. So of course, the moon regulated months, which is super common. A little bit later on, there was the adoption of a lunar zodiac, essentially coming from the Indian nakshatras, but brought in as an Islamic version of the lunar zodiac as the lunar stations. And so this was basically 28 individual stars or star groupings that used the indigenous names for them, but put them into this new structure. And so those basically come from, each night the moon stops for the night at one of these star groupings. And so they're the lunar stations. Sometimes they're translated as lunar mansions. That's not really the sense here in Arabian astronomy, although I understand that's more of Chinese lunar zodiac piece there. But yeah, so those 28 groupings became very important. So the rhymed prose that I showed, initially that was, prominent stars and stars that had stories got rhymed prose. But when the lunar stations were adapted for use in Arabia, then the ones that didn't already have rhymed prose got rhymed prose as well. And so they were often transmitted as this package of 28, each with its own rhymed prose. Okay, and next steps for me. So I'm very much trying to get a book out. Looking for publishers, working with various approaches to this. I would like to present the Arabian astronomy completely outside the context of Greek astronomy. So you don't learn it through Greek astronomy, but on its own merit. But I also know that because so many of these indigenous Arabian star names survive in names we use today in astronomy, like Vega and Altair and Aldebaran, Rigel, Betelgeuse. These are all indigenous Arabian astronomy names that probably I need to make 2 books. So there's one for, amateur astronomers and whatnot with maps and everything, so they can get to that quickly from what they already know. But I really want to present it also on its own merit. We grow up learning astronomy as we received it from the Greeks on its own merit, and we can do the same for Arabian astronomy. So those are kind of, I guess, 2 projects that I'll be working on next. In the end, sure, having some of this in Stellarium would be great. I'm also looking at perhaps a Starry Night plugin. The challenge, though, with both of those is, the internal organization is not set up really well for Arabian astronomy, because we didn't get into this very much today, but there's a layering of star names and meanings on single stars or groupings of stars. So, the 4 stars that make up what we know today as Corvus had 4 different names depending on context in Arabian astronomy. Some stars like Aldebaran, goodness, that has like 7 or 8 names. And so it becomes really problematic with, Stellarium, for example, to get all of those into this Arabian shell. So I'll work on the books first and then get to that other piece later.
It's funny you should say that, because in Ojibwe, Dakota, and Innu, the maps that I've worked on, we have that same thing. So there could be one constellation, but it could be 3 or more things. And so, well, which one do you pick to actually draw on the map? Or in some cases, there could be a combination, a layered combination. But when there's gets to be 3 things for one place in the sky, then it kind of gets confusing. So it is, you're right, at a very fundamental level, it's not the same as like this one-to-one linear mapping. It's much more layered, more indigenous, in fact.
Yeah,
so
and the challenge there is like, you don't want to create false priorities by choosing one and then saying it also meant these. Because that's not really how it was. Some actually may have been used that way. You know, some certainly had a prominent name and then others that existed. But, you know, when you do that, then you flatten the sky again from its texture. So it's challenging.
Yeah, well said. So, Kate, a question for you. It must be really difficult to teach astronomy during this pandemic time. What do you think this project, the Stardust project, has done in terms of engagement? Could you give us any details there on how that's unfolding for your students and your team of educators?
I was just talking about this with our dance teacher, who's also one of the mentors on the project, about how motivating it is to have a creative project, to get to collaborate on, to get to come together, to work across disciplines, as you all were talking about earlier. Like, it's a fun thing for us to do, and it's invigorating. And for many of our students, you know, and for all of us, it's been a long year. It's been a long winter, and to have something like this to look forward to has been really nice, and has given us energy to keep going forward and to be creative.
Things that give us energy. That's a good point. And Tavia, a question for you. What do you think the importance of theater is in our world? And, you know, there's so many kids or art programs being cut, Broadway being shut down, but I think I heard it was being reopened soon. But as someone who is vibrant and active in that field, this connection between the theater arts in particular that maybe doesn't have an immediate pathway to our underrepresented students, like an obvious pathway, sort of like with museums, like, you know, maybe not a lot of our underrepresented students have had that experience of going to a Broadway show or live theater. What do you think we are missing when we don't have theater, and what does it bring to us into our lives and our students when we do have it?
Wow, that's a lot. Well, I guess I would first just say that I think, first, I would say that theater is happening all the time around us and in informal ways all the time. And that I refer to just as performance. And sometimes people aren't even aware that they're an audience or aware even that they're the performer, right? And that's an interesting thing to think about once you start sort of using that as a lens to view performance. I like a lot of us here, I'm also a teacher, and I teach at a state school here in Baltimore called Towson University, and I teach classes, you know, sometimes that, you know, that fill out the arts, you know, the arts code for the bingo card to graduate, right? So I often have, you know, nurses and scientists and football players and people in my students in my class, and some of them have never been to see a show. So this is their first time. And depending on where people come from, how they might view that show or expectations for the show culturally might be very different than from what we see here. Sometimes audiences are really loud. Sometimes shows are interactive. Sometimes you're supposed to be very quiet and only read your playbill. That's why I don't go to too many Broadway shows. I'm more of the loud interactive type. But I also, I mean, I think that theater needs to be taken back and away from ticketed events and taken out into the streets and used to share and change the way that the world is. I mean, theater before, you know, art and performance was before there was even language, right? So when you're, building the fire in the cave to keep warm, but you got to go out. You have to let someone know that there's, a saber-toothed tiger out there, right? So how do you express that? We got to shove grandma closer to the entrance or whatever, like all these classic things, but you had to communicate. It's just a way of communicating, but how you layer it and what you define as beauty is really defined as the culture and the people that you're with and create. But I do believe theater has the power to change minds and change the way that we evolve as humans.
Nice. I think I remember you saying too that there was some really successful programming that you did with kids wearing masks, and that kids that like it's the opportunity to be anything else, to explore, to say anything in this honest way because you're behind this shield. And I know that like Janice Bad Moccasin at our previous event talked about when the horse puts the mask on, then that's when the horse like transformed, this transformative moment through the mask, and it became a spirit friend and a healer, not just the physical horse. So I thought that was fascinating how you talked about the students behind mask and using the mask.
Yeah, and I mean, I think it doesn't even necessarily have to be a mask. It could be a hat or a costume. Like all of a sudden you transform into something different, right? And you do that when you look through up at the sky too. So it's about transporting, I think, too.
Nice words. And also like the opportunity to play. It seems is connected to theater. Play with light, play with sound, play with performance, and just play like we were all kids again. So to wrap it up, I see the hour's getting late. Danielle, there was a question. There was a comment. I'm looking for Indian astronomy. So that would have been for Raja. Maybe he can address that later. But there was someone was asking about Chinese indigenous astronomy, if you had any references or any ideas. So we're just seeing interest in this global sense. Did you have anything? Maybe not, but.
Yeah, there's quite a lot of research on Chinese astronomy. So I believe David Pingree is one who has worked on Chinese astronomy. If you email me, just go to the Lowell website and you can find me there and email me, and I can get you some more details there.
Fantastic. Okay, any closing words from anyone? Want to have anything want to say before we wrap it up?
I would just again love to thank you for this whole series. This is now the wrap-up event after the official wrap-up event, and it's fantastic. So really hope that even after the fact that we can drive a lot of people to the website and still have people taking part in those sessions afterwards. So thank you, Annette.
You're welcome. It's been a lot of work, but it's been really, really meaningful work. So I'm really glad for this opportunity.
I wanted to say thank you, Annette, too, for your vision on this. It's been a big vision, and it's coming to fruition. Thank you.
Yeah, I feel like in some ways we've been working, it's been like a lifetime of work, but in some ways it's just the beginning and the tip of the iceberg. So I'm really looking forward to the next things with all of you as well. Tavia?
I just wanted to say thank you, Annette and Raja and Raja's team and all of you for being here and making this possible. And Danielle, I want to warn you because I'm hopefully driving my boys across country this summer. So we might just come and visit you and check out the telescope.
Love it. Yeah, let me know.
Perfect.
Yeah.
Perfect. Okay, so just another quick reminder, you can see this Native Skywatchers, the next event is June 14th and 15th at our huge, just a really celebrity-packed lineup. for those two. It's supposed to be 2 half days, sort of like 9 to 1, and we'll be showcasing Kate's South Middle High School, their videos, whatever they produce, maybe a dance. I can't wait to see. And so we just welcome you. It's completely free. And Danielle, I'm going to check out some of those events on the Lowell website, because I was totally sold when you were talking about it. So take good care, everybody, and we look forward to continuing, and great that we made this this happen. So Pilamia with all my heart.